What's going on, guys? So in front of me, you are looking at what could arguably be known as the Area 51 of the RV industry. This is the research, development, and testing facility for Lippert. So this is where components that they manufacture go to be tested. This is where their engineering teams are, where they design and engineer and come up with new products and new solutions. They also test those here. But they also look at third-party companies or other companies that produce components that claim to work well on their frames and their chassis, and they also go here to test them. So there's a lot of folks who are always looking at products and saying, is this going to work with my RV frame? Is this going to be something that Lippert approves as a compatible part to our RV frame? And this is where they get those components, they test them, they put them through the cycles to see if they will withstand the test, but also not present a problem to the frame that it will be installed on. So let's head inside. All right. So again, this is research, development, and testing. This area is super cool because a lot of the products that you may choose to buy, a lot of the components that come on the RVs that you buy will probably start here in a testing phase. They'll put them through cycles and they'll see exactly how well they hold up and what impact they have on the frame itself. So this is also an area that a manufacturer who creates a part for an RV might send their part, or you may get that part so you can specifically say, well, we know how much stress that part is going to put on our upper deck, or it's going to put on our frame, or after, you know, pulling it down the road for X number of miles, what it's going to do to the chassis. And you have a bunch of parts up here. You have a bunch of different components that you all, I'm assuming, put through the test. So if you can, real quickly, introduce yourself again and then just kind of go over what we're looking at today.
My name is Mark Hess, and I'm the Director of Engineering for Chassis Division here. And again, what we're doing here is testing all the components to make sure that they work and interact with each other in a system, just as the RVs are. So that's why we've got competitive products. Some of it's benchmarking, of course, but some of it also is to make sure that everything interacts and plays together nicely at the end of the day.
Yeah. And at the end of the day, we know that Lippert produces a lot of towing components themselves, right? And this is something that, of course, you want to be able to tell people, you know, a Lippert product can provide these benefits. But you're not saying that other components aren't good components. You're not saying that a Moride pin box or a Demco pin box or these are bad components. You just want to be sure that any of these other brands, when used with your frame, don't potentially cause damage to the frame section, right?
That's correct, yeah. At the end of the day, we want our consumers to have a good experience. So.
Yep. And I believe you're going to be coming up with a website or a way, an actual database where people can actually go and see if the pin box, if a component is approved for use on your frames. Because one thing we noticed right off the bat when we were walking through the frame assembly plant, you don't actually put suspension components on the RVs when they roll off. You don't equip them with an equalizer, with leaf springs. That's all put on by the OEM RV manufacturer. They pick the components they want. And a lot of RV manufacturers may pick a component that they want to put on the RV frame itself, and you just want to ensure, or at least advise them, we've tested it, we know what type of impact it's going to have. We know if it's going to cause potential issues. We put it through the cycles. We either recommend it or we don't recommend it, or we certify it or we don't certify it. Yep. One of the reasons why I use a Reese Goose box is because it's approved by you all for use on your frames. Again, we talk about Moride. We talk about other products. These are approved for use on your frame, even though you have your own product.
Yep.
But they've gone through the tests. They've gone through that process of ensuring that they're not going to damage the frame by the standards that you subject them to,
correct,
right?
Yep.
So if it's not approved, why wouldn't a product be certified or approved to be used on a frame?
Again, the interaction, we got to look at the stresses that it's going to put in, how it's going to transfer into the chassis itself. So sometimes, you know, pins are in different locations that just pushes stress differently into the unit. So we just got to make sure that everything is designed to work together.
Okay, and again, you have no problem certifying a competing product as long as it doesn't potentially cause damage to the frame. Yep. And that damage may not even be noticeable for 20,000 miles, 30,000 miles, right?
Yeah, fatigue sometimes takes a long time. You know, there's two phenomena. There's ultimate failure and then there's fatigue. And fatigue sometimes takes a long time to present itself.
Absolutely. So really cool. show us what we're looking at in here, because we have a lot of really interesting things going on. They shut this factory down for me so we could talk and kind of go through things, and then we can turn different components on here to test them as we want to demonstrate them.
So let's start over here with the upper deck testing. So here we've got a setup where we can put a vertical pin load on a complete upper deck and test this through. Again, you can see there's no walls or there's no main rails here, or just a section of main rails, but this allows us to test the joint of the pin box and the fasteners and all the welding there, as well as the upper deck main rails to the cross tubes and the upper deck risers.
Okay. Now this is also your Space Saver deck. So this is your newer generation of upper deck. And how much equivalent pin weight are you applying to it on this test cycle?
About 25% is usually our standard.
Okay. All right, so something that is interesting to know, and one thing we talked about, is the amount of weight that a typical pin box is going to either apply to a vehicle, or how that's going to change based on the floor plan of the vehicle. So what they like to test here is to 25% of the GVWR of the specific trailer application that this upper deck will be put on. So if this is a 20,000 pound GVWR, then you're going to test this to 5,000 pounds.
Exactly.
Okay, so that's a really, really good example. But in reality, you should really be between maybe around 15 to 20% typically of pin weight, right?
Correct.
Okay, so you're testing it by a margin exceeding what the actual pin weight should be on the vehicle. And of course, when we're talking about toy haulers, especially large toy haulers, the toy that is supposed to go in the back is designed to offload some of the pin weight.
Yeah, so unloaded versus loaded will be substantially different, or could be substantially different.
So a question I have for you is, when a customer buys a toy hauler, and let's say a 44-foot long toy hauler that has a cargo carrying capacity of 5,000 pounds, and I guess I'm just throwing arbitrary numbers out here, but they have no intention of putting a toy in the back. They're going to use it as an office or something that, you know, hardly has any weight in the back. Are you potentially subjecting that chassis to a scenario where you have excessive pin weight on the front because it's designed to carry a toy in the back that's going to offload some of that weight?
I mean, it will be carrying a higher percentage, but I think that's a trend that we're seeing more of. Based on the testing that we do, I don't anticipate that causing any issues.
Okay, so you already take that into account, though. It's just going to be more pin weight on the tow vehicle, so you have to be sure you have the capacity. So a good example of that is if you have a 20,000 pound GVWR toy hauler with no toy. Well, first of all, if it's not a toy hauler, if it's a standard RV, you're probably going to transfer maybe 3,000 to 4,000 pounds worth of pin weight to the back of the vehicle. Yep. But if it's a toy hauler and you don't put toys in it, you have nothing to cantilever that weight off of the back or remove weight from the tow vehicle, then you could be transferring 5,000, 5,500 pounds potentially to the tow vehicle.
Could be, although without the toy, the chances of getting right up to GVW are probably quite a bit lower.
Okay, well, I don't know. Some people can find ways through battery packs and solar systems to do the equivalent. Okay, so yeah, this is really cool. So what are we going to reflect in this test right now? What is this test going to show us?
So this is going to show us a vertical load at the pin.
Okay, and is this a cycle test? This
is a fatigue test. Yeah,
okay.
This is a cycle test. Yep.
Okay, let's go ahead and turn this one on if we can. How much movement are you looking for?
We're not specifically looking at movement in this particular test. We're really looking at the fatigue. The next stand over there is where we're kind of looking at the deflection side of things. But, you know, this is not untypical. The walls provide about 50% of the stiffness over the overall unit.
And a lot of people don't realize that. They don't realize that the frame is designed and inherently it's going to have flex built into it, or that movement ability, whereas the walls and the superstructure of the RV that's built on top of the frame needs to be built to the recommended standards in order for it also to carry and to prevent some of that movement.
Correct. The other thing to note is we've got the main rails tied down here very close to really where we're applying the load. You know, if you have a unit that's 40 feet long and, you know, your axles are back quite a ways, you're also going to get some of that flex into the main rail. So what you're seeing here will certainly exaggerate it more. And that's one thing to really keep in mind when you're doing a subsystem level test.
Okay. Very cool. All right, so we're done with this one. Let's move on to the next one. right, so what do we have going on here?
So what we have going on here, this is a static strength testing area. So we do test things to ultimate strength. So when we've got pin boxes, for example, where we're testing them to the ultimate strength until they fail, or travel trailer coupler, safety chains, that's all gets done in this area. What we have set up here specifically today is an upper deck, and we're looking at deflection. We've got linear displacement transducers several places around the unit so that we can measure the deflection and see exactly where it's going and map it out at the pin box, at the corners, and then at different places down the upper deck main rails as well.
Okay, let's turn this one on if you don't mind.
Yep. This one is a little bit less exciting because it's just a static load, and then we're taking deflection measurements all around, and then we'll map it out. Again, we've got different designs. We've got the 2x8 7-gauge here, main rails, but again, we can compare this to 2x6 quarter wall, 2x8 quarter wall.
Okay.
All those different options. Structural C.
Do it.
So we just went up to achieve static load, and then once we reach that load, then we release the pressure.
Okay.
We've collected all the data. These are all wired into the computer, so we're collecting displacement versus time, and then we can get graphs looking at displacement versus time, displacement versus load, and use that as part of our engineering process.
And how many cycles do we generally go through on a test like this?
A lot of these tests like this, just like the pin boxes we'll see here in a minute, are 900,000 total cycles.
900,000 cycles.
300,000 in each direction.
Okay.
You've got braking loads and other loads besides the vertical that we're showing.
Okay, let's move on. One thing I spotted here is Rotaflex. Now, Rotaflex is a pin box that you can get on a lot of RVs. It's a very common pin box. And when I usually talk about it to people, I say that you have a pivot right here, you have a thick rubber bushing right here, and it allows it to dampen some of that shock and load whenever you're going down the road, limiting some of the vibration shock from transferring from the trailer to the truck to the trailer. But you guys don't just test it in one direction. What's going on here with your different tests on Rotaflex?
Okay, the SAE requirement for a pin box test is that you test it dynamically in 3 different directions. One is a vertical test, one is a longitudinal, which would be braking and gas, and the other would be transverse, which would be side to side. This particular direction right here is a transverse test. So this test needs to go 300,000 cycles. Each of the 3 directions goes 300,000 complete cycles. This is transverse. We've got another one down here on the end. We can show you that that's longitudinal, and that specifically is testing the type of motion that you're talking about, that the real reason that this box exists. When you do a longitudinal test or a transverse test, the test standard allows you to apply a vertical load. They call it a vertical stabilizing load because there's going to be a vertical load on there. And some pin box designs really need that vertical load to make them function correctly. If there's a spring in here, you don't want to test it with the spring all the way out.
Yeah, that's true.
It needs to be in the operating range.
Okay.
So this one has a vertical stabilizing load on it. And that is what this cylinder is doing. It applies a vertical stabilizing load. This cylinder here is the one that applies the longitudinal load. That's a full load reversal.
Okay.
So
let's check it out. Let's see how it looks and performs. The sound you're hearing is actually coming from up here. That's really cool. That is a great demonstration of how Rotaflex works. Very good. Okay, so we've shut the machinery down, and you kind of educated me on what type of test this actually is. It is demonstrating how it works, but this isn't a real world test per se, right?
Correct. This is a structural test to ensure that the steel components of the pin box will withstand the fatigue of an entire lifetime of abuse.
Yep, and how many cycles does this one go through on here?
300,000 cycles in each one of the 3 directions.
Oh, wow.
So 300,000 longitudinal, 300,000 transverse, and 300,000 vertical.
Okay. And I'm assuming all the hitches that you test, whether it's a Lippert produced product or it's a competitor, does it go through these tests, at least the ones that you test, to see how it performs and what type of impact it has on the frame structure?
Correct. But we're looking at it for how it interacts with the chassis. We're not testing it to certify their performance. Correct.
You just want to see how it impacts the chassis it's going to be installed
Correct.
on. Okay, perfect. All right, I like what I see here. This looks really cool. So I'm all about RV suspension. And I see road armor in here right now. I see leaf sprung suspension. Looks like 7,000 pound axles. Let's turn this one on because I want to see this. There's a lot of folks who are like, well, how does road armor really work? And you can film it underneath your RV. But this test right here is one that's going to be super cool because I'm not exactly sure what this is going to look like when they start running it. And I can see they can test it in multiple directions as well. Okay, so what are we testing here exactly?
Yeah, so here we're looking at axles, springs, and equalizers. One thing that's really awesome about this piece of equipment is that it has a motion controller, and we're able to test it in various different modes. So what you saw a minute ago was out of phase front to back. We can also run them in phase front and back, or out of phase left and right. Like you mentioned before, there's ability to put some lateral load in there as well, like a turning motion. Mm-hmm. So those are all different things that are certainly important for the springs and axles, and we're able to test them out here in a fatigue sense.
Yeah, no, that is awesome. And it just, again, goes to the fact that you all are testing the things that you put on RVs, or the things that people will install on RVs.
Absolutely.
And a lot of times you test them to the point of possibly failing.
That's correct. Right? We don't want someone broken down on the side of the road. So.
Yep, exactly. And just like Jared said in an earlier video, you don't want warranty claims. You want the product to be able to withstand what you subject it through, because a warranty claim is typically an upset customer who has a problem with something and may be stranded. And the better built these components are, the less likely someone will be in that scenario.
And this really allows us, all this stuff here allows us to accelerate that testing, right? So rather than, take in months at a proving grounds or years in the real world, we can really accelerate this. And sometimes in, days or hours, get some feedback on what's going on.
Yeah, very nice. All right, so we've wrapped up with a lot of the testing. We've talked about kind of the mindset behind how they test and evaluate different pieces of equipment that could potentially, put your entire RV at risk if it's not tested properly. And we've talked about the fact that they do have a certification program, and they want to be sure that any piece of equipment you attach to your RV is capable of towing your RV without damaging the RV itself. So you definitely want to make sure that you review and research any product you plan on putting on a fifth wheel or a travel trailer to ensure it's not going to do more damage to the actual unit than you're trying to prevent by using that product. That's going to wrap up this video. Next video, we're going to focus in on a brand new product, and it's right there. Okay, so Lippert is still in the development phase of this specific product. I think some people can probably get an idea of what it is, but you're definitely going to want to check out the next video because we're going to go really in depth into what you're looking at in front of you. Guys, if you haven't had a chance, please take a moment, subscribe to the channel, give me a thumbs up, and we'll talk to you again very soon.